Dear students, in the last sessions, we had learnt about some simple electric circuits. We have noticed how the current through a conductor depends upon its resistance and also on potential difference across the ends of the conductor. So in various electrical gadgets, we often use resistors in various combination. We now therefore let us study how Ohm's law is applied in the combination of resistors. We are going to study about combination of resistors. Okay. What are resistors? First, we have to know what are resistors. Already you had studied about resistance. Yeah. What is resistance? It is the property of an object to oppose the flow of current. That means resistance is a property. But here the resistors are that object which resist the flow of current. Okay. So resistors are the object which resist the flow of current. Yes. You can see here in the picture the resistors, right? So where it is having a color band, so this resistors resist the flow of current. Where it is used in electrical circuits, in some electrical appliances. So there are two types of resistors. The first one, that is fixed resistors and variable resistors. So you can see here the fixed resistors have only one resistance value. Okay. So they are carbon resistors, also called as carbon resistors. And you can see in the picture the other resistor, that is the rheostat, that is variable resistors which can be adjusted to change the resistance. So that is rheostat. So this fixed resistors and rheostat which you can see in your physics lab. Okay. So these are the two types of resistor. This is carbon resistor, or also it is called as fixed resistors, and this is rheostat, okay, or wire bound resistor. So when this is used in a circuit, when these resistors are used in a circuit, they try to resist the flow of current in the circuit. Okay. How much is the magnitude of resistance of this resistor? That also we can calculate. What is here fixed resistors, right? So it is having some value of resistance. How can we calculate it? That is by looking the color bands. You can see, observe this color bands on the resistors. You can observe the color bands, right? So based on this color band, the value of the resistance is calculated. But this calculation you are going to learn in your higher classes, that is class 12 in second PU science. You are going to study it, how the resistance of this resistors are calculated by using this color band. Okay. Now in this syllabus it is not that. So next, so wire bound resistor means, what is wire bound resistor? This is rheostat, is called as wire bound resistors. So why it is called so? Because it is wire bound means so on some metal over which number of turns of wire, you can see number of turns of wire is present. That entire thing is called as a resistor. Okay. So here there is a upper jaw where it can be adjusted. The resistance is adjusted. Okay. It is varied. So to make or design electric circuit, we often use resistors. Why do we use resistors in electric circuit? Yeah, why do we use electric resistors? That in order to prevent huge amount of current flowing through the circuit, because it might happen when extremely high current flows in the circuit. So it might spoil the electrical elements present in the circuit. For example, let us suppose take an example of a refrigerator or any other electrical appliances which is present at your house. Okay. If a huge amount of current passes through it, then many of that components may get damaged, right? So to prevent that huge amount of current flowing in that circuit, we use resistors. Okay, resistors are used in this components. So there are different ways in which resistors are arranged in a circuit. There are different ways. All electrical appliances are having resistors. Okay, so there are different ways in which these resistors are arranged in a electric circuit. In fact, they are broadly combined into two ways, where there are two ways in which it can be combined. So let us study that. So why are these resistors combined? Why we have to combine the resistor? Let us suppose in order to design a circuit, you have a specific requirement. Okay, suppose you are designing some electric circuit and you want that only some amount of current should flow through that circuit. Suppose you want 5 ampere of current is required to design a circuit. Okay, take an example, you want 5 ampere of current. For that you want a specific value of resistance to be present in a circuit, right? So that specific value of resistance is achieved by combining the resistors. So how to get the specific value of resistance in a circuit? So I had shown you the resistors. It is having some resistance. It is fixed resist. This resistors, fixed resistors are having some fixed resistance. Okay. So which now if you want a specific value, this is not available in the market. Okay, but all possible value of resistance of resistors are not available in the market. So that time if you require 99 ohm resistor which is not available in the market, in such cases where you want specific value, the time we combine the resistors which are available to get the desired value of resistance. You are getting my point, right? So to achieve the specific resistance which are not available, okay, so that time we are going to combine the resistors. So in order to make our desirable circuit, when we want some specific value of resistance, sometimes we combine the resistors to get that particular value of resistance. So as I told, there are two ways in which resistors can be combined. Okay, so which are the two ways of joining the resistor? That is resistors in series, or it is called as series combination. And next, resistors in parallel, which is called as parallel combination of resistors. So there are two ways of combination of resistors, that is series combination and parallel combination. Okay, so in order to increase, for example, when we want the resistance of a combination is to be increased, that time we are going to combine it is in series. And when the resistance of the combination is to be decreased, means if the combination of the resistor is to be decreased, that time in order to pass heavy current in the circuit, they are combined in parallel. Once again I will repeat, when the resistance of the combination is to be increased, they are combined in series. Resistors are combined in series when we want high resistance, and the resistors are combined in parallel when we want low resistance. Okay, when the resistance of a combination is to be decreased in order to pass heavy current in a circuit, they are combined in parallel. Got my point? Series combination is to increase the resistance. Parallel combination is done to decrease the resistance in an electric circuit. Okay. Similarly, now let us learn first about series combination of resistor. Okay, later on let us learn about parallel combination of resistor. So now series combination of resistor. Okay, resistors in series. You can see here there are, let us consider three resistors, that is R1, R2 and R3, which are joined end to end. Here the resistors are said to be connected in series. Okay, when do we call the resistors are in series? When the resistor, you can see here the resistor R1, R2 and R3 is connected end to end. Okay, so this kind of combination is called as series combination. So one end R1 is connected to the source, and R1 one end is connected to R2, and R2 one end is connected to R3, and R3 other end is connected to the other end of the circuit. So this is how the series combination is done. Okay, this is resistors in series. This is a simple electric circuit which represents the series combination of resistor. Okay, so all understood about the how the series connection is done, that is end to end connection. Okay, in this three resistor, that is R1, R2, R3, let us consider the current which is flowing. So you can see here the current I which is flowing in this electric circuit, right? So in each resistor, let us consider the current I which is flowing in the circuit. Okay, so here in series combination, the current I flows through resistor R1. That means the same amount of current flows through the resistor R2 and R3 as well. Okay, so through each of them the same amount of current is flowing. Current I is flowing through all the resistors. Same amount of current is flowing through each resistor when the resistors are connected in series. So current flowing in each resistor is same. So when the resistors are connected in series, current flowing through each resistor is same. Okay, however, the potential difference across each resistor is different. So you can see resistor R1 is having potential difference of V1, resistance R2 potential difference V2, and resistance R3 potential difference is V3. So for the whole electric circuit, that is for resistance R1, R2, R3, the potential difference is V. For resistance R1, the potential difference is V1. For resistance R2, potential difference is V2. And for resistance R3, potential difference is V3. For whole equivalent resistance, let us take it as RS. For that, the potential difference is V. Okay. So, resistors in series, you have to remember, current through each resistor is same. These are the main point which you have to remember in this topic, that is when the resistors are connected in series, that means end-to-end connection, that time the current through each resistor, the current which is flowing, is having a single path for the flow of current. Okay, that means current through each resistor is same, but potential difference across each resistor is different. Here current I flowing in R1, in R2 also current I is flowing, in R3 also current I is flowing, but potential difference is not the same for R1, R2, R3. For R1 it is V1, R2 it is V2, and R3 it is V3. So if you take the total potential difference, we are going to get, that is V is equal to V1 plus V2 plus V3. So if we apply Ohm's law for that electric circuit which is in series, so let us see now. Here the figure shows three resistance R1, R2, R3 which are connected in series. Now suppose potential difference across the resistance R1 is V1 and R2 is V2, and across R3 the potential difference is V3. So the potential difference across the battery, that is V, for the whole circuit the potential difference is V. Then what happens to the total potential difference? Total potential difference V is equal to sum of the potential difference across the resistor, that is V1 plus V2 plus V3. Therefore V is equal to V1 plus V2 plus V3. So if we apply Ohm's law for the circuit, what Ohm's law states, that is V is equal to IR. Let us consider it as equation 1. Applying Ohm's law to the whole circuit. When we apply to the whole circuit, we are getting V equal to IR. So if you apply the Ohm's law for each resistor, for resistor R1, if you apply Ohm's law, that time it is V1 equal to IR1. I because same current is flowing through all the resistor. So V1 is the potential difference across R1. Therefore V1 is equal to IR1, V2 is equal to IR2 and V3 is equal to IR3. Let us consider that as equation 2, 3 and 4. Now substitute equation 1, 2, 3, 4 in this value. V is equal to V1 plus V2 plus V3. Substitute the value of V, V1, V2, V3 in this equation. So if you substitute, you are getting V is equal to IR, right? IR is equal to IR1 plus IR2 plus IR3. So it is IR is equal to IR1 plus IR2 plus IR3. So here I is common, that is current is common. So current get cancelled. I and I in the right hand side and left hand side, I get cancelled. So what remains, that is equivalent resistance R is equal to R1 plus R2 plus R3. So what is the conclusion here? The sum of the total resistance in a series resistance connection is equal to sum of all the resistance. Okay, total resistance, that is RS, let us take, or R equivalent is equal to sum of all the resistance, that is R1 plus R2 plus R3. So resistors in series, when the connection of resistors are in series, what you have to remember, which are let us conclude this resistors in series, that is when three resistors R1, R2 and R3 are connected in series, that time the current in all the resistor is same. This is the first point. Current in all the resistor is same. Second point, the total voltage, that is potential difference across the resistor, is equal to sum of the voltage across each resistor. That means total potential difference in an electric circuit is equal to sum of the potential difference in each resistor, that is V1 plus V2 plus V3. Okay, next third point which we have concluded, that is equivalent resistance is the sum of resistance of each resistor, that is RS is equal to R1 plus R2 plus R3. This equation gives us the resistance, that is RS is equal to R1 plus R2 plus R3, gives us the equivalent resistance of series combination of resistor. So this equation is used to calculate the resistance when the resistors are in series. Okay, if two resistors are given, that means RS is equal to R1 plus R2. If there are four resistors, then R1 plus R2 plus R3 plus R4, like that. It is the sum of the resistance of resistors. Okay, so this is about resistors in series. Next, let us study about the parallel combination of resistors. So what happens when the resistors are connected in parallel? You can see here the three resistors R1, R2 and R3 are connected in each end of the resistors are connected to one point, and the other end of each resistors are connected to the other point. You can see both the ends of resistors are connected to each other. That means the ends of all resistors are connected together, right? And the other end of the is connected together in terms of this circuit diagram. Okay, so you can see here, this is the circuit diagram for parallel combination of resistors, where R1, R2, R3 are connected in parallel. You all have understood about parallel combination, how it is connected. All the ends of the resistor, that is R1, R2, R3, one end is connected to one point and the other end is connected to the other point. Okay, so here you can see current I which is flowing in the circuit. Here it is having different path, right? It is not having a single path to flow, but here as the current I moves, it is going to split. That means here the current is, it gets split up, that is I1, current I2 and current I3, which flows in each resistor. So in resistor R1 current I1 is flowing, and in resistor R2 current I2, and in resistor R3 current I3 is been flowing. Okay, so here the current I gets split up into three resistors. The amount of current is depending on the resistance of the resistor. Okay, so here in parallel combination the current through each resistor is different. So in case of parallel combination, current through each resistor is different, but in case of series what it was, current through each resistor was same in case of series, but in parallel current through each resistor is different. Next, potential difference across each resistor is same in case of resistors in parallel. Potential difference across each resistor is same. So at two ends A and B, the potential difference is V. So for all the resistance, the potential difference is same. Okay, potential difference is same, but current through each resistor is different in case of parallel combination of resistor. Okay, if current I flows in a circuit, the current gets divided across each resistor, that is I1, I2 and I3. But potential difference between the 2 points, that is A and B, this potential difference between these 2 points is same. The voltage is same. Okay. So now if we apply Ohm's law for this combination, that is parallel combination of resistor, so in this case we can say that total current flowing through the circuit is, so in this figure if you see resistors are connected in parallel, the current across the resistance R1 is I1, the current across the resistance R2 is I2, and current across R3 is I3. So let what is the total current in the circuit then? That is I is equal to I1 plus I2 plus I3. So if you add all the three, I1 plus I2 plus I3, you are going to get current I. So applying Ohm's law to the whole circuit, the time if we apply Ohm's law, I is equal to V divided by R. Ohm's law, electric current I is equal to V divided by R. Consider it as equation 1. So by applying Ohm's law to each resistor, that is R1, R2 and R3, what it happens? Current I1 is equal to V by R1. Here potential difference is same across all the resistor. So it is taken as V. Okay. So I1 is equal to V by R1, I2 equal to V by R2 and I3 is equal to V by R3. You can see here, consider this as equation 2, 3 and 4. So equation 1, 2, 3, 4, you substitute here I is equal to I1 plus I2 plus I3. So we know that from equation 1, I is equal to V by R is equal to I1 is V by R1 plus V by R2 plus V by R3. If you substitute I value, I1 value, I2 and I3 in this equation, you are going to get V by R is equal to V by R1 plus V by R2 plus V by R3. Here potential difference is same. So potential difference on the left hand side and the right hand side cancels. So we get 1 by R is equal to 1 by R1 plus 1 by R2 plus 1 by R3. Therefore, we conclude that sum of the total resistance in the parallel resistance connection is equal to the sum of the reciprocal of all the resistance. Okay, so this equation represents the parallel combination of resistance. So this is used to calculate 1 by R is equal to 1 by R1 plus 1 by R2 plus 1 by R3. Here 1 by Rp let us consider because it is for parallel. So 1 by Rp is equal to 1 by R1 plus 1 by R2 plus 1 by R3. So this equation is used to calculate the total resistance when the resistors are connected in parallel. So in the next class let us study about how to calculate the resistors when it is in series and when it is in parallel. Okay. So these are the two types of combination which are possible So depending upon our requirement, we are arranging the resistors in a circuit. So the two types of combinations are possible, that is series and parallel. So resistors in parallel, you have to remember these points. When three resistors R1, R2 are connected in parallel across AB, what happens? The voltage of the resistor remains same, and the current in all the resistor is the sum of the current in each resistor, that is I is equal to I1 plus I2 plus I3. And the third one, the reciprocal of the equivalent resistance is the sum of the reciprocal of each resistance. That means 1 by Rp is equal to 1 by R1 plus 1 by R2 plus 1 by R3. So this is about resistors in parallel. So these are the two ways of combination of resistor: series combination and parallel combination. Okay, in the next class let us study the problems related to this and what is the difference and what are the advantages over series and parallel. Let us discuss in the next class. Okay, next section let us do that. So hope you all have understood about series combination and parallel combination of resistors. Try to understand the concept. Okay, thank you.